Hello everyone and welcome back to another video. In this video we're going to cover section 6.1 and it's on rational expressions and functions, multiplying and dividing. So let's begin with writing down some examples of some rational functions. So we talked about them a little bit earlier in an earlier video, but technically 3 over 4, this is a rational expression. If I made it f of x equals 3 over 4, then it would be a rational function. What about f of x is x over 3x squared plus 1? That's a rational function. And remember, what characterizes rational functions is you have a polynomial on the top, a polynomial on the bottom, just like here and here, or here and here technically too, because numbers are polynomials as well, right? They're just constant polynomials. So this is a ratio of polynomials, 3 and 4. This is a ratio of polynomials. It's x to 3x squared plus 1. So both of these are rational functions. So now what we should do is we should talk about how we multiply and divide rational functions. Well, what's really, really nice is that when multiplying and dividing rational functions, it works almost identically to how we multiply fractions. So just recall, to multiply two fractions, say we had 3 over 4 times 7 over 11. Let's say we're given this example, we're supposed to multiply this. We're supposed to multiply these two fractions. Well, remember, we just multiply across the top to get 21. We multiply across the bottom to get 44. That's the same, it's going to be the same idea with rational functions. So with rational functions, let's suppose that we have 3x over 4, yeah, that's fine, 3x over 4 times, how about 2x cubed over x plus 1. Let's just say we wanted to multiply these two together. Well, we'll multiply across the top, so we'll get 3 times 2 is 6, so 6, and then x times x cubed gives us x to the 4th. And then on the bottom we just have 4 times x plus 1. So one more thing we could do is just notice that there's a common factor of 2 that goes into both 6 and 4. So dividing that out, we get 3x to the 4th over 2 times x plus 1. One thing to note is that when we multiply these fractions together, we're viewing this as a single quantity. So that's why we have to remember that there's parentheses when we get to this step. So I can also just insert them here. But even if these weren't here, we would still need them in this next step. All right, so that's an example of multiplying two rational functions together, or two rational expressions together. So next we'll look at dividing. Well, thankfully dividing rational functions or rational expressions is exactly the same as how we divide with fractions. So remember, with fractions, if we had, say, so this upper part was multiplication, and for the lower part, we're going to talk about division. So division, it's identical to how we deal with division with fractions. So let's just suppose we have 2/3 divided by 9/4. Remember, every division problem can be viewed as a multiplication problem. This is the same thing as 2/3 times the reciprocal of 9/4. So remember, the reciprocal just flips what we have, so it becomes 4 over 9. Awesome. Now we just need to multiply across the top, multiply across the bottom. It's exactly the same as it was up here. So multiplying across the top, we get 8. Multiplying across the bottom, we get 27. So that's how we divide fractions. Well, remember, fractions are rational expressions technically, right? We have a constant on top and a constant on the bottom. So when we go to divide rational expressions, let's say we have 3x squared over let's say 9. Here we'll have two variables just for fun. So 3x squared over 9y divided by, let's say, 20y squared over 4. Let's say we've got, or how about 7? Okay, here we go. Well, we treat it just like we did with the above problem. We turn it into a multiplication problem. So we rewrite the first part, 3x squared over 9y divided by, but now instead of divided by, we turn it into a multiplication problem, and then we flip over the fraction. So we flip what we're dividing by. So we get 7 over 20y squared. Now we just need to take this and simplify it over here. Well, notice we've got a 3 on top and a 9 on the bottom. So that means we just really have a 3 on the bottom. So dividing the top and bottom by 3 gives us this. So this is the same thing as 7x squared over, and then we have 3y times 20y squared. So 3 times 20 gives us 60, and then y times y squared gives us y cubed. So this is the final answer to this division problem right here. So this is the end of this video, guys. We'll see you in the next one where we cover maybe some more complicated examples and we talk about the domains and yeah, I think just the domains of these functions. And then in 6.2, we'll go on to adding and subtracting rational functions. So I hope you guys like this video. We'll see you all in the next one.